right, ladies and gentlemen, we're going to take a look at lesson 2.8, which is graphing absolute value equations. We've solved absolute value equations, but now we're going to take a look at the graph of those. So what we're going to do is study what's called a standard form. Many of our equations have standard form. Linear equations have the standard form y equals mx plus b. Our absolute value functions are going to have a standard form of y equals a times the absolute value of x minus h, and then plus some k value. Now what happens here is these h and k values that we see in our equation come together to make an ordered pair. This is the x value of our vertex, and this is the y value of our vertex. What we need to keep in mind is that we're always taking the opposite of h. So that's why it's x minus h. We take the opposite of it. A is going to work as our slope. So that's going to be our rise and our run of our function. The other thing we know then, once we get away from looking at the equation, when we look at the graph of an absolute function, it is symmetric across the vertex. So what does that mean? It's the same on both sides. So your absolute value functions are actually going to have a V look to them. And the reason for that is the absolute value of a given quantity is always positive. So if I multiply that by a positive A, I'm going to be going up. If I multiply it by a negative a, I'm going to be going down from that. But this is what we call the vertex. So these points right here are our vertex. And then we have our graph going down, and it's symmetric across that vertex. All right? So let's take a look at our first example. I'm going to want to go dual screen, and then let's see what I want to do here. We are going to pin this one. So let's see if that works for us. We want to graph y equals the absolute value of x. That's our basic, what we call the standard function. The first thing you're going to do when you graph is to find that vertex. So your job is to find h and k. That's what we're going to do. So h, if we go back, h is what's being subtracted from x. If we look at that function, we just have x. Nothing's being subtracted from that, so our h value is 0. Okay? If I don't see anything there, then I have to qualify it with a 0 under addition and subtraction. I need to find the k value. K is what's being added to the absolute value of the function, and the same thing, there's nothing outside there. So that means my k value is 0. So I'm going to plot that point, 0, 0. I now need to count the slope, which means you should probably find the slope of the function. That's your a value. So a is what you're multiplying the absolute value by. All right? If we look at our absolute value, we aren't multiplying it by anything other than 1. We have 1 times the absolute value of x. So we're going to have a rise and run of 1. So from that vertex, we're going to count up 1 over 1. And we're going to make this graph. This is pretty easy. So we have that. We're going to stop there. Notice I'm only going from that vertex. I'm only counting to the right-hand side. So we're only going to go to the right for right now. Once you're going to do that, you're going to take 2 or 3 points and reflect them across the vertex. So if you need to, draw in a line of symmetry, something that you can reflect that over. So this point is 1 unit from the vertex, and so we're going to reflect it 1 unit over. This point is 2 from that vertex, so we're going to reflect 2, and then we're 3 over, and then we get this lovely graph. You will always have a V shape. That's what we know about absolute value function. You will always have that. So if you're not creating a V, you know something's wrong. All right? So let's take a look at the next example. Example 2. We need to graph the function y equals 4 times the absolute value of x. I need my vertex. I need h and k. I need to find my A value. So if we look at that, it looks very similar to the last one we graphed, except for the fact that we have 4 times that absolute value. So hopefully most of you have already filled this in. Our vertex is 0, 0. I'm not subtracting anything from x inside the absolute value. There's no change to x, and I'm not adding anything. So my vertex is 0, 0. My A value this time is 4, which means my rise is 4. I have a run of 1. So on my graph, I'm going to go up 4 over 1, up 4 over 1. We run out of room rather quickly. Graph that and connect it. We're going to put an arrow there because just like our linear functions, it's continuous. It keeps going. But what I need to do now is reflect this point. So I'm going to reflect over. I was 1 unit away. We need to draw that dashed line in. 1 unit away, 2 units away, and there's my lovely V. But we should only have a V for our absolute value functions. All right, so I hope we're doing okay with these first 2 examples. Wherever I lost you at, put a question mark, circle it, star it, so we can ask about it tomorrow. All right, example 3. Now we're starting to see some changes within our function and what we had from the original. I need to find h and k for my vertex, and then I'm going to have to find some a value. So h is what we're subtracting from x. We're subtracting 3. So if you read this as a -3, my h has to be a +3. I'm still not adding or subtracting anything outside of the absolute value, so this is 0. So now my vertex is at 3, 0. So what's happened here is I've moved away from the y-axis, and so it's going to be pretty important that we do draw in that line of symmetry at this point. So I'm going to highly recommend that. That's the point that we have, if we fold our graph over that, the right and the left-hand side of our graph will line up with each other. My vertex is, my A value is -1/2, which means I'm going to go down 1 and I'm going to go over 2. So that means down 1. We're going to go right 2, a negative move and a positive move. So I'm going to go down 1, right 2, down 1, right 2, and I kind of do that until I run out of room on my graph and I connect those. And now my last step is to reflect those. So this is 2 points away, 2 units away. So 1, 2. I need to go 1, 2. Here's my point. This is 1, 2, 3, 4 units away. 1, 2, 3, 4 units away. 1, 2, 3, 4, 5, 6 units away. 1, 2, 3, 4, 5, 6 units away. And then we connect those. If you need to erase all those little dots that you created, which means those of you who take notes in pencil, this is pretty easy. But if that's what we need to do to be able to count our symmetry, then that's fine. So now we see we actually have a graph that opens down, which is what we know about negative slope. It should be decreasing. So all of those positive absolute values were multiplied by a negative, and now they open down. Let's take a look at example 4. So really what I've done here, guys, is just continue building on what we have. First step, find h and k. I take the opposite of what I have in there. So if I'm adding 2, the opposite of that is -2. And this time I am adding something. I've got this +3. So k is what we see. If it's +3, it goes in as a +3. My a value, you cannot forget that. If we don't see anything, that means we're multiplying by a 1 there. So our slope is 1, which means up 1, right 1. We're +1, so our graph should be going up. So my vertex now is -2, 3 for that. And we should be drawing a line through that. Once again, this is where my symmetry is at. So it's shifted over 2 spaces. I'm going to count slope from that vertex, up 1 over 1. We're going to get a few good points, connect those, draw our arrow, but then we're going to reflect those points. So I'm going to reflect over 1 unit, over 2 units, and then you can kind of just make sure they line up. You still have that 1 slope, but it's going now in the opposite direction, and there is our V. Once again, guys, wherever you have questions, please stop, pause the video, mark it up where you had your questions at, underline it, star it. All right, number 6, our 6th slide here is example 5. We need to list the vertex, the direction, whether it opens up or down, and whether it is wider or narrower than the original function that we graphed, y equals absolute value of x. Well, let's graph this one and see what happens. So I have a vertex of -3, -5, the opposite of this, and then what I'm adding. And then my slope is -2. So we're going to graph -3, -5. Draw in a line of that line of symmetry for that. Count my slope, down 2 over 1, down 2 over 1. And then we're going to reflect those points. All right. So my vertex is here. My slope is -2, so it opens down. Now I need to know whether it's narrower or wider. So what I'm actually going to do for you guys is graph what it would look like if I had a slope of 1. So my slope of 1 would be down 1 over 1, down 1 over 1. And so you notice when we have a slope of 1, we actually get this wide graph. Down 1 over 1, down 1 over 1. All right? So our green graph here is actually narrower. Now, is there a way to determine that without having to graph y equals absolute value of x every single time? There sure is. I'm going to be wider than y equals absolute value of x if a is greater, if a, the absolute value of it, so the positive or negative doesn't affect it, if it is less than 1. So that means if we have fractions. All right, you need to be careful what types of fractions, but they have to be proper fractions. It's going to be narrower if the absolute value of a is greater than 1. All right, so we'll do some practice with this tomorrow, and I'll have a couple of questions that I'll ask you to look at that. But that is all that I have for you tonight. Have a good evening.